Alright, this is the final video for the midterm review. This will cover Unit 5, which is on chemical reactions. Alright, chemical reactions are basically the process by which atoms of one or more substance are rearranged to form different substances. Basically a chemical change. There's two parts. There's the reactants, this is basically what you start with, and there's the product, which is what you end with. We've talked about evidence of a chemical reaction before, and they're basically the same. You're going to have some sort of chemical or temperature change. You can release energy in the form of light and heat. You can also absorb energy. You can have you can have a color change, which kind of goes hand in hand with a solid here. So these two kind of go hand in hand. Also, you can get an odor or the presence of a bubble. And in this case, that's typically showing you that you have a creation of a gas. And there's 5 different types of chemical reactions. The first is synthesis. It's where you take two elements. So you have element 1 plus element 2 that basically are going to combine together to give a compound. Combustion is where you're going to take some sort of hydrogen and carbon and occasionally oxygen, combine it with oxygen, and you're going to get CO2 and water. This will always contain carbon, hydrogen, and oxygen as reactants, so this should be pretty easy to pick out. Decomposition is where you take a compound and you're going to break it apart into different elements. Okay, so we have element 1 basically from the compound plus element 2. Okay, it's basically the opposite of synthesis. The 4th type is single replacement. That's where you're going to take an element plus a compound, and the element is going to replace one of the elements in the compound. So that will give you another element in the product plus a compound. And to tell whether this reaction will actually occur, you can use what we call an activity series. We'll see that in a second. But the element that is trying to replace the other one must be more reactive. And typically metals will replace hydrogen or another metal, and a non-metal will replace a non-metal. A metal cannot replace a non-metal. Our next type is going to basically be 2 compounds combining together, this is called double displacement, and that's going to give us 2 compounds. Alright, so with these types of reactions, you could be asked to identify the reaction and then predict the products. Well, if we look at our first example, we could see that we have psyllium and oxygen, okay? And these are going to combine together to give us a product, because we have 2 elements basically. So if we have 2 elements as our reactants, that is going to show us that we are going to have a synthesis reaction occurring, because you're going to take the 2 elements together and you're going to make a product. So the first thing we know is that we are going to have a synthesis reaction occurring. Okay, so if we have a synthesis reaction occurring, with this one in particular, we have 2 nonmetals combining. And when I looked this up online, it gave me a product of SeO3. However, if you were to give me SeO, SeO2, I would also take that. This is the type of one where I would have to take multiple answers. Alright, the second reaction they give us is going to have C2H4 plus oxygen. Well, we have a carbon-hydrogen molecule with oxygen. That's combustion. So automatically we know that our reactants are going to be carbon dioxide and water. So if you can identify what type of reaction it is, you should be able to predict the products. Alright, moving on to our next example. This deals with the single replacement reaction and using our activity series. So it basically says determine if lead, metal, and aqueous silver nitrate can react. If so, predict the products. So we write down our lead plus our silver nitrate. So we write that in formula form. And then we go over here. This is our activity series here on the far right. What you're looking for is our two compounds. So here's lead, here's silver. Lead has got to be more reactive, which means it has to be higher on our list than silver, which it is. So our reaction can occur. So what's going to happen is this lead is going to replace silver, and silver is going to go off by itself. Well, we're not quite sure what lead's charge is. It is a transition metal, so I just said it was lead 2. So we would get lead 2 nitrate and silver would be our product. Again, this could have been, the other thing I could have taken was lead 4, which is our other option typically. Excuse me, it should be 4. Write this. Which is the other one that you're often going to see, plus silver. So in some of these, when you're having to predict the products, I'm going to have to take multiple answers. Alright, so the chemical equation, which we were just predicting the products on, is going to be a way to represent what is actually happening in a chemical reaction. We've got a couple different symbols that you may have noticed that we're talking about. You have a plus sign that's going to separate the reactants from each other or the products from each other. You have an arrow sign that separates the reactants from the products, and we often say this as yields or produces or creates, something along that lines. Makes is typically how you read that. And then we have 4 states of matter. We have solid, liquid, gas, and aqueous. And aqueous we will get more into in a minute, but that's basically a solid dissolved in water. Now, when we're talking about the actual chemical equation, we also have numbers written in front of our compounds, what we call coefficients. And this is going to help us balance the equation. So how do we go about balancing our equation? Well, the first thing is, if they're given the equation to you in a descriptor form, in word form, you have to write the basic equation. Then you count the atoms in the reactants, you count the atoms in the product of each element, and you have to put coefficients in so that way you can equalize the number of atoms of each element in the reactants and in the products. Once you get all your coefficients and once everything's balanced, you want to ensure that everything is in the lowest possible ratio. So meaning that if all your coefficients are divisible by 2, you want to go ahead and divide them by 2. So let's look at our example. Write the balanced equation for the reaction. Solid potassium reacts with liquid water to produce hydrogen gas in a solution of potassium hydroxide. Alright, so the first thing we gotta do is take all those words and put them into symbols. So that's what I've done. We have K plus H2O goes to H2, which remember hydrogen's diatomic, plus KOH. So let's look at it. We have 1 potassium, we have 2 hydrogens, and we have 1 oxygen in our reactants. In our product side, we have 1 potassium, 3 hydrogens, and 1 oxygen. Okay? Well, let's think about this for a second. We need to get our hydrogens separated, or equal to one another, excuse me. Well, in the product, they're separate. So we don't necessarily have to have a common multiple between the two. We can, however, multiply our one in the reactant by a number, and that will increase. So let's just try 2. So if we put a 2 here, we put a 2 in front of that, that would change this to 4 and this to 2. Okay? Well, now we still have, we still have what we had in the products. Okay, well now let's put a 2 in front of the KOH because we need to make sure that we have 2 oxygens here. So that's going to make that 2 That's going to give our total of 4 to all together. And we still only have 1 potassium. So we're going to need to put a 2 in front of the potassium there, which will give us 2 potassium. And that will balance everything out. Okay? So let's look. If I were to erase all that, let's look and see what we got. Okay, that's exactly what we have. We have 2 potassium, we have 2 waters, 1 hydrogen, and 2 potassium hydroxide. So if we go back and count, we have 2 potassiums, 4 hydrogens, and 2 oxygens in our reactant. In our product, we have 2 potassium, 4 hydrogens, and 2 oxygens. Well, now we're balanced. You don't necessarily have to make the little table. If you can do it in your head, great, but a table may help. Alright, so I mentioned earlier that we had aqueous solutions. So aqueous solution is basically where you have 1 or more solutes dissolved in water. These solutes are often solids. So solute is what is dissolved in the solution. So if you have a hot chocolate mixture, your hot chocolate is your solute. The solvent is what's doing the dissolving, which is going to be water most of the time. Particularly for aqueous solutions, that is the solvent. Okay, you combine them together, and you get your solution. Now, with an aqueous solution, you have a solid. So in this case, we have sodium chloride that will dissolve in water. It's going to get surrounded by water. So it's basically going to have sodium and potassium ions, and whatever else is dissolved in water floating around. The main thing a lot of you guys have been missing is that these are ions in solution. It's basically what an aqueous solution is. So keep that in mind when we go forward here. Okay, to represent these reactions between the aqueous solutions, which is really reactions between ions, we have a couple different types of reactions we can use. Now, all our aqueous solutions are going to be represented with ions. Solid liquids and gases are going to be represented as compounds. Now, our two big equations that are different than what we were talking about. You've got your overall balanced equation. Then we can look at what we call our complete ionic. That's where we take anything that's aqueous and we break it apart into its individual ions. We can also look at this point and see what we call our spectator ions. These are the ions that do not participate in the reaction. They're just sitting there floating around. And the way you tell this is if the ions are the same, exactly the same in the reactants and the product. Again, these are going to be ions. So if you have something that becomes a solid in the product, that can't be a spectator ion. And our other new type of reaction is known as the net ionic equation, our other type of equation. This equation shows just the core of what's happening at the reaction. It's the simplified version of the reaction. So let's look at an example. We have a molecular equation. This is your balanced equation here. This is the balanced equation. This is what we just talked about. Okay, we have lead 2 nitrate. We're mixing with potassium iodide. We get lead 2 iodide and potassium nitrate. This is that yellow solution I did when I was doing the demos. Okay, so that's your balanced equation. Now, if you notice, we have 3 solutions. Both reactants are aqueous, and one of our products are aqueous. So when we go into our complete ionic, we're going to take each one of these, and we're going to take each part and break it into the individual atoms. Okay, so we have lead plus 2, aqueous. The 2, because we have 2 nitrates, comes out front. We have 2 NO3 negative. Okay, we have 2 potassium ions, because this potassium goes, or that 2 goes distributed there and to there. So it's to both potassium and iodine, which we see. Okay, that's our reactants. The lead 2 iodide stays together. Again, the 2 is going to be distributed between the potassium and the nitrate. So we have 2 potassiums and 2 nitrates. Now, let's look at both the reactants and the products. Okay? So, if you notice here, we have potassium both in the same format. So, we're going to cross these out because they are one of our spectator ions. The other one, nitrate, is the same here and the same there. So those are our spectator ions. So what's left over is what's going to make our solid. So you can either do the complete ionic and mark out your spectator ions, or you can just simply look at your solid here and think about, okay, what do I need? Well, I know I need a +2, and I know that I need 2 iodine to make this solid, okay? And that's what you see here. Your net ionic is just lead +2 iodines leads to lead 2 iodide. Alright, and there are a couple different types of aqueous solutions you're going to see. The first is a precipitant forming one. This is the most common. Now remember, a precipitant is just a fancy word for a solid. And often you're going to get a color change, and you can use your solubility rules to determine or to predict if a reaction is going to occur. So, remember, if it's soluble, if it shows up as S, it's going to stay as an aqueous solution. So it's going to be AQ. If it's insoluble, it's going to become a solid. So you'd have the phase of a solid. So make sure you keep those straight. A lot of y'all have been having issues with keeping that straight. The other type of reaction you're going to see is one that produces water. You're going to increase your solvent, and you can't really see this other than, like, say, measuring the pH. This typically happens between acids and bases. Alright, and then the third and final type of reaction you're going to see is going to produce gases. A lot of times you'll see bubbles with this. The most common type of gas you're going to see in here is going to be carbon dioxide, and occasionally like hydrogen. Hydrogen cyanide gas and hydrogen sulfide gas are not as common. Alright, so let's look at an example here. It's a little long, but just bear with me. Write the balanced equation, complete ionic, and net ionic equations for the reaction aqueous solutions of lead 2 nitrate and ammonium chloride mix. Alright, so the first thing you got to do is you got to take those and you got to put them in word form. Okay? So, we've got to write our balanced equation. We have lead 2 nitrate plus ammonium chloride. Okay, well this is double displacement, so we know we're going to switch partners. So one product is going to be PbCl2, and our other product is going to be NH4NO3. Alright, so if I look at my solubility rules, okay, I know that ammonium nitrate is going to be aqueous, whereas lead 2 chloride is going to be a solid. So I know that this is what I'm really going to care about. But we got to do our complete ionic. Okay, so our complete ionic, we're going to take anything that's aqueous here. Anything that's aqueous. So this one, and this one. And we're going to break it apart into its ions. So we have lead +2 goes to 2 nitrates, because remember we have 2 of them, plus 2 ammoniums, plus 2 chlorines. Again, that 2 out front is going to be distributed to both the ammonium and the chloride. Then in our products we keep lead chloride together, and we have 2 ammoniums and 2 nitrates. Okay? Well, this should be easy because at this point we should be able to pick out what our spectator ions are. Okay, well nitrate is the same in both spots. Ammonium is the same in both spots. So then that should leave us with just our net ionic, which is lead +2 goes to chloride, 2 chloride minus 1 creates lead 2 chloride. Alright, that ends the 5th video, and this ends the review for the midterm.